Hello everyone and welcome to this transfer of information on AOS-CX 10.7. For this session, this is about S-Flow egress direction. My name is Vincent Giles. I'm part of the Aruba Switching TME organization. And the agenda of today would be the TOI agenda, that is the overview of the feature, the use cases being considered, details and caveats, configuration for S-Flow, best practices, a bit of troubleshooting before we dive into the demonstration, and finally resources. Let's first start with the overview and a reminder of some acronyms: S-Flow, NetFlow, and IPFix, as there were no S-Flow TOI made before. So S-Flow means sampled flow. This is an industry standard for packet counting and sampling and exporting those information to a collector. The current version is version 5. It can be used Ingress before 10.7 and now Egress, that is the feature enhancement, or both Ingress and Egress on an interface. Don't get confused by the other two that are important. So this is NetFlow and IPFix. NetFlow is the Cisco proprietary information. NetFlow version 9 was actually the basis and the foundation of IPFix, and that support Ingress, Egress on both. And IPFix, which is the standard, the ITF protocol for a flow information aggregation and export. So S-Flow is a sampling technique, whereas IPFix is a flow aggregation information. So there is no packet information being lost with IPFix. So IPFix is identical to NetFlow version 10. It can apply Ingress, Egress, or both. So let's remind you on S-Flow and as a technology. So this is a monitoring technology for traffic crossing switched or router. The S-Flow monitoring system has two parts. First, an agent that run on the switch or router, and then a collector. So the agent will sample the captured traffic and send the counter and the sampling to the collector, whereas the collector will aggregate the information that the network administrator can analyze and understand the traffic pattern and the flow trend on the network. The agent forward to the collector two types of UDP datagram, so the interface counters, samples, and that is regularly made based on the polling interval, and will also export flow samples based on the sampling rate. So this is one packet out of n packets seen on that interface. So the S-Flow datagram structure is based on the UDP with a port that is configurable. By default, this is 6343. The default sample header size is 120 bytes, but it can be tuned to 256. The max datagram size as the number of information contained in the UDP is by default 1400 bytes, but it can also be extended. And the important aspect is the agent IP that will be used to identify the S-Flow source device in the collector. So in the collector, that information is inside the S-Flow datagram. Don't get confused to the source IP address of the S-Flow traffic generated by the switch. That can be different. So that source IP address generally is the source IP of the router for the path to reach the collector. However, it can be changed as well with, for instance, the loopback given loopback address. We can also select a given VRF to source that traffic for S-Flow data. Pay attention that the S-Flow samples are not encrypted, so therefore any sensitive information might appear in the datagram of the S-Flow datagram. So the CX features set for S-Flow in CX before 10.6 is listed on the left side. So we have S-Flow version 5. So we support traditional header that is Ethernet ISO 88023. We support the counter packet as a generic interface counters. However, there is no support for extended S-Flow header. So you have here a link to the standard, okay? And anything that is prior to the extended flow data in that standard is supported. Anything below is not supported. As a matter of fact, you will see that, for instance, the VLAN-ID is an information that we do not have for S-Flow export data out of CX. Something that we need to also take care is that the ingress sampling before 10.6 and before 10.6 CPE, by the way, to be very accurate, the ingress sampling is done after VXLAN decapsulation. So it means that the S-Flow is sampling the overlay traffic, not the underlay. So you don't have the VXLAN header. So it has changed in 10.7. And it was only ingress. So as 10.7 enhancement, we now support egress direction on top of ingress for all the Rosewood-based platforms. So that are the 6200, 63, 64, and 8360. There is a caveat about the S-Flow and VXLAN combination. So this is a summary here. I will get back into the details of that in the details section of the presentation. So, but here you have, as in overview, a caveat of how the S-Flow, does the S-Flow sample the data before or after VXLAN encapsulation or decapsulation. This is the information that is summarized here. And there is also some aspect of pending optimization for that. So just to recap on what we do not have, for instance, as unsupported data. So anything that is, again, extended flow data is not supported. VLAN-ID is one of it. So you will see here on the Wireshark that inside the sample packet, you have the IP packet, and it's not even if this is an Ethernet frame with the trunk, for instance, you do not have that information in the sample. So the basic supported data are the protocols, the Ethernet frame length, the sampling header, the basic sampling header that we have here. And for 10.7 pipeline order for egress, so egress S-Flow sampling happened before the VXLAN encapsulation. So here there's the raw packet that is taken from an output of the interface that carry VXLAN. You see that there is no VXLAN header. So this is interesting, by the way, because this shows you the overlay traffic, which is probably the most interesting part for the network admin. Let's get into the use cases. Why egress S-Flow? So solving the problem on ingress-only S-Flow. So on the left side here, for instance, let's consider different administrative domains. So domain 1, let's say this is the customer, and domain 2, this could be the carrier, for instance. So the problem with ingress only is that, first of all, if you want to analyze what is going to the one, you need to, as those core equipment will aggregate many, let's say, buildings, you need to have all the interfaces of those equipment facing the one carrier to be configured with S-Flow on all ingress interfaces. So that provide an extra stress on the CPU, as this is, even if the sampling is done in hardware, the export of those data and information is done by the CPU. So the less interface you configure for S-Flow, the best it is for the health of the device. So this is something to consider. So everything needs to be configured ingress. So that's a problem. And it will count the ingress traffic, even if you've got filtering in place on those equipment. So it means that anything that is going out of the equipment might not be equal to everything that has been received, because specifically for ingress or egress access list that you may have. So it does not give you neither the the proper volume of data that that ingress is seeing compared to what really egress would be. So that's the first use case. A second one that is an interesting one as well is the one for any-to-any monitoring. So let's say you have 3 sites, site 1 communicating to site 2, site 3, and so forth. So with Ingress-sFlow, let's say on site 2 and on site 3, it requires to have ingress on all those interfaces. So this is a bit like before. If you want to really see what is going on the one circuit, you have to have ingress on all the downlinked to each of those core equipment on the site. So like before, right? So that point is the same. The second point is that the sum of all the ingress data in site 2 and in site 3 does not necessarily equal egress data of site 1, because you may have site 3 going to site 2 in terms of traffic. So you cannot, by looking at ingress flow, extract information or assume information for egress. So that's an issue. Okay, so with that model, you have no capability to really find what is the real egress on the site. And Ingress-sFlow is most of the time a must for the network admin to monitor and to sample and audit the one circuit. So typically to check against what the carrier is providing as an information on a monthly basis about capacity planning and so on. So that are the 2 use cases that are driving the need for sFlow egress direction. So let's get into the details. So that table summarizes everything that is supported for sFlow on AOS-CX as of 10.7. So we have the interface counter, we have the sample, so that's the basic 2 things that I talked about at the beginning. We have the header size that is configurable, the datagram size that is configurable as well. We support sFlow on lag. Okay, so that's an important aspect on lag or VSX lag. We don't support sFlow on tunnels. So whatever it's a GI tunnel or VXLAN, this is not supported because sFlow, as a matter of fact, is sampling packet on the wire and not on virtual interface. So any virtual interface, we won't support sFlow on those. Unlike PVOS, we do not have instance or profile support of sFlow where you could set specific parameter per instance. So that concept of profile for the configuration of sFlow per instance is not something in CX. We can enable or disable sFlow in the global context without losing the configuration. And we can also unconfigure with a single line of command sFlow globally by simply doing no sFlow. It will remove all the configuration for sFlow. We can enable or disable sFlow per interface. So by default, sFlow will be enabled globally, and on all interface, sFlow will be enabled when enabled globally. And you can restrict the number of interfaces running sFlow by disabling each interface individually or by a range command. The sampling rate is set by global context, inside the global context, so and not per interface. The polling interval, it is the same. This is a global configuration, not per interface configuration. Likewise is the mode, the ability to do an ingress, egress, or both. That is a global context, not per interface. The sFlow IP, the agent IP, that is used in the collector to identify the node that is sourcing the traffic can be IPv4 on IPv6 is something that you can configure. You can as well configure the source IP address that is used to issue the S-Flow UDP datagram to the collector. Again, this could be different than the agent IP. Typically, the agent IP would be the loopback. We'll see that in the best practice. The S-Flow can be exported to multiple collectors as a 3 maximum. Each of them can be over a different VRF. The UDP destination port is configurable, so that's 6343 by default. And you can use any VRF that is needed with a maximum of 3 different VRF, as you support up to 3 different collectors in the S-Flow configuration. The VRF can be management, so it means that the S-Flow collector can be reachable through the out-of-band management port. We don't support any S-Flow MIB for reading or writing, so in some collector allow you the ability to configure S-Flow on the device with SNMP. We don't support that. There is a bunch of show command for S-Flow, and you can also clear the statistic globally or per interface. In terms of support for 10.7, here is the list of the platforms that are supported for Ingress and Egress for S-Flow. So as you can see, this is fully supported Ingress and Egress on 6200, 6300, 6400, 8360. 6100 is not yet supported for Egress, neither on 8320, 8325 or 8400. Please note that S-Flow is fully supported on a VSF stack of 6200 or 6300 as well. So the combination of S-Flow and VSF is supported. Some aspect that needs to be highlighted with in regards to the combination of feature with S-Flow. First of all, the Ingress access list. On all platforms, S-Flow is agnostic to any access list rule on the Ingress. So it means that whatever there is a deny or a permit on the traffic, the S-Flow will sample the packet. So this is important to notice that even if you do a deny all, there will be sampling happening. So as in the pipeline, S-Flow is doing sampling before access list is performed. So a note for 8400. So this is still Ingress only as of 10.7 right now, but S-Flow is, when enabled, the port mirroring cannot be enabled. So those restrictions are documented, but just as a reminder, if port mirroring is enabled, S-Flow can be enabled, but you won't get the sampling. You will just get the counter being exported. Sampling won't be active. So that's as a consequence, if there is a reboot, the combination of mirroring and S-Flow is non-deterministic. It will be based on which one is applied first. So if S-Flow is enabled and a policy is applied, a policy that would drop a packet, the sample that is matching the policy for drop is dropped. So there is no export of that information to the collector. So contrary to the access list here, the traffic is not sampled if it is dropped by the policy. If S-Flow is enabled and there is a mirror policy that applies, the mirror policy will take precedence and the sampling will not happen. Now, a restriction on the 8320, so that is still Ingress only, no Egress yet as of 10.7. So if S-Flow is enabled and you have a drop policy, so like we described on 8400, the sample that match the drop policy is drop. However, the sample is sent to the collector. So the drop policy is processed, and the sample is sent to the collector. So this is different than the 8400. And on the 8320, the S-flow and the mirroring policy can coexist, unlike on 8400. Next is about specifically on Rosewood platform, the feature combination. So there is no problem with Ingress-S-flow and mirroring on those platforms. And before, since 10.6, it has been fixed. Before we had an issue. Now in 10.6 it is solved. S-flow egress sampling, please take a note, would be rate limited by what we call a copy protection meter. And the rate limiting will be exactly up to a limit of 1984 packets per second per switch. So it's not per interface, it's globally per switch. And if you hit that limit, the distribution of the sample across the port on the device will not be equal. So pay attention to that. So the egress packet are not sampled if there is an access list denying the packet and apply to the S-flow enabled port. So if you've got an egress access list that is filtering out the traffic, there is no S-flow sampling being performed on that packet. The packet is dropped and the corresponding statistic information is not performed. If there is a policy that is going to drop the packet, this is the same. The egress sampling is not performed. The combination of egress sampling and on the port connecting the collector. So this is a very niche corner case, but just to make sure that you have the information. If you connect a collector to a port on which you apply egress S-flow, and you have a sampling rate that is 1, that is not going to work. So this is not supported at all. So that, again, should not be a customer use case. Combination with VXLAN. This is the important aspect. So we have two columns, whether it's Ingress and VXLAN being combined, or egress. For Ingress S-flow, the sampling is done before VXLAN decapsulation. So if there is a remote VTEP receiving VXLAN traffic, if on the interface receiving the VXLAN traffic S-flow is enabled, S-flow statistic will poll and export underlay information with the VXLAN header included. For egress on the same platform, Rosewood platform 62, 63, 64, and 8360, for egress, the S-flow sampling is done before VXLAN encapsulation. So on the local VTEP, there are traffic that is destination to a remote VTEP encapsulated in VXLAN. If you enable egress S-flow on the interface that exits where the VXLAN traffic exits, the S-flow statistic is related to the overlay. So the VXLAN header will not be included. So there will be an alignment of the behavior that we saw before for Ingress that is tentative for 10.8. Right now as of 10.7, so there is different behavior for Ingress than egress. For 8325 and 8400, that are still for Ingress only, so there is no egress as yet for that concern. So this is roadmap. For Ingress, the sampling is done before VXLAN decapsulation. So this is as same as the Rosewood platform. And then we'll go to the configuration of S-flow. So to configure S-Flow, we go to the global context. There is the S-Flow command, and this is the list of all the parameters you can set. So the agent IP, the collector information, the destination of those export flows, if you enable or disable, header size, datagram, the mode, ingress, egress, or both, the polling interval, and the sampling. So if you do a no S-Flow, you will remove all the configuration for S-Flow. If you do S-Flow disable, you will just disable S-Flow without removing the config. This is just a simple extract of a running configuration with S-Flow parameters being configured here. And per interface, the only parameter that you can configure per interface is if S-Flow is enabled or disabled. You can set S-Flow through the API. On Swagger, you've got two entries, S-Flow and S-Flow collector, and you can use that curl command if you want to, with that dataset, setting in the global context all the information that I explained in the CLI, you can set that through the API. This is an example where here what we have now is the mode where you specify egress now, that is the update of 10.7. And please note that in the name here on the dataset, you need to specify global as a name for the resource, the reference resource for S-Flow. Let's go to the best practices. So first of all, it's probably good to have a loopback address of the switch being the agent IP. That's easier for the network admin to dive into the collector and to see exactly what is the agent in his database. We support up to 3 collectors. Generally, we use 1 collector or maybe 2, but not more. This is technically possible and supported to enable S-Flow on all interface. We have that capability, and you will see that there is a COP policy that prevents a CPU to be completely overloaded for S-Flow. Remember that S-Flow sampling is done in the ASIC, but the export to the collector is done by the CPU. So this is recommended to collect the traffic information only from really the meaningful interfaces in the network. So this will minimize the CPU load if you do that. And again, that's the CPU is used for exporting the S-Flow data to the collector. So this is a short recommendation that we have here for the campus and the data center. So typically on the campus, we'll have S-Flow enabled on the aggregation circuits. So the links, the downstream links going to the aggregation service blocks. On the aggregation device, we'll have the links to the access switches or the mobility gateway. In the data center, we can activate the circuits between the spine and the leaves. So that could be on the spine. If you need that, or as an option, you can do that as well on the leaves. Okay, so the connectivity to the spine you can activate here instead of the spine, or on top if there is really a need to have that as well on the leaf. Specifically for the border leaf, that would be useful to activate S-Flow to the firewall or to any WAN or MAN routers. Something specific about the sampling rate. So as you can imagine, the sampling rate is something sensitive, because if you are very aggressive on that sampling, you may impact the CPU. So generally speaking, the default sampling and polling timer are good to use, and don't change them until very specific request from the customer for some troubleshooting, for instance, for a given period of time or for very specific reason. If you try to configure the sampling rate lower than 4096, you will get a warning, which is there. Setting the S-Flow sampling to a lower rate on very high-speed link could have a really high impact on the CPU. So for very high-speed links like 40 gig or 100 gig, we may even ask to minimize the sampling rate. This is a table that is provided as a guidance if you need to decrease the sampling rate for whatever reason the customer would need. And in that case, that would be something that would be the maximum sampling rate that is recommended. So for 10 meg, that would be 1 over 200, 100 meg, that would be 1 over 500, and so on. So for 10 gig, that would be maximum 1 over 2000. So obviously, it will depend a lot about the traffic and the volume of traffic that you have on those circuits. Let's go into the troubleshooting section. So first of all, the show S-Flow. We have here for it was a stack of 6300. So we have the ability to check if S-Flow is enabled. So this is the first thing that you would need to check if the status of S-Flow is running. So this is in step B here. Then that would be useful to check if S-Flow is enabled on the required interface that are important for the user. If there is a problem of setting S-Flow on that interface, you should have sampling being performed on the port. So that line here, those information, port is not sampling, refer to a problem that happens to activate S-Flow on those ports. So that should not, that port status here should be empty and should not appear. Again, please make sure that the good practice is followed in order to activate S-Flow on the meaningful interfaces and with the sampling rate that would limit the CPU load. Then the S-Flow agent is going to perform an ICMP echo request to each collector, and that would be made every 5 minutes. So this is a fixed period you cannot change. That would be to check the reachability of the collector. So if there is nothing below the connector status here, it means that the status is green and okay. So I ask for an improvement of that so that it's a bit more explicit that the status is either green or running when instead of nothing. If there is something like unreachable, this is a problem of connectivity between the S-Flow agent and the collector. And something useful is to verify the global statistic of S-Flow are incrementing. Next is the same show S-Flow but at interface level. So typically you will check that the S-Flow is enabled on the given interface. You'll check that there is a S-Flow sampling that is successful, and as well that the sample ingress or egress are increasing. So please note that show S-Flow interface will show the option for physical interface and lag interface that are valid S-Flow enabled interface. You may see as well that there is a VLAN, SVI, and VXLAN interface. So this is something that is going to be removed probably in future versions because again, these are virtual interfaces that S-Flow cannot be enabled on. So there is no point to actually propose that option in the show. Then when there is an issue and you previously check all those parameters, you can really take a look at the collector. So first of all, you can ping the collector from the switch to check against the network reachability. If the samples are not seen on the collector, well, the best is really to check the collector configuration as well. You can check that that collector is properly configured for the UDP port that is configured on the switch, so that both values are matching. You can also run a netstat to verify that the collector is listening to the configured IP address that is the collector IP, because the collector may have multiple, this is a server, so it may have multiple IP address, and also the UDP port. So if the sampling rate is not achieved, so you see effectively on the collector there is less number of samples than you expect. So probably good to check the COP policy, the control plane protection. So you have to check the default COP policy if this is the default applied. Here it was the default that was applied in my case, and you'll see on Rosewood platform that S-Flow has a drop priority of 1 and rate limit and burst. So good to have as well a show COP policy statistic class S-Flow and see if there is any packet being dropped. So this is something important. Then more troubleshooting would be a diag dump S-Flow. So that is here. And possibly, if this is something that is feasible on the customer side, to identify and classify the type of traffic that are not seen and the sample not being generated. Is it unicast? Is it broadcast, multicast, and so on? Then you have the debug command where you can check that S-Flow is activated on those ports and being enabled on those ports. And then we'll go to the demonstration part. So for the demo, before diving directly on the equipment, let me explain you the topology and what we are going to do. So this is a VTEP here, a local VTEP, and here a remote VTEP. So we got VXLAN traffic going through an underlay, and we use that topology in order to understand the combination of VXLAN and to see if the VXLAN traffic is being captured or not. So on the left side is a VSF stack of 38360, and we activate S-Flow, and the configuration of S-Flow is the following, with the mode that can be ingress, egress, or both. For this specific TOI, we want to focus on egress, so we'll change this configuration to have egress only. And then we can activate egress on all the interfaces or only on a specific interface. So we'll see the difference. So then what we do is that agent, that S-Flow agent, will export the data, the S-Flow data, to a collector. So that machine here run two things. First, the S-Flow collector as such. So we are using for that a freeware. So that's from Inmon. So Inmon, it's actually Inmon who invented the S-Flow protocol. So they are the founder of S-Flow, and we use their tool that is called S-Flow Trend. So that's for free, and you have the ability at least to check basic things that S-Flow agent will export to that collector. And then we run as well Wireshark to dissect all the S-Flow packet received on that system to analyze exactly what S-Flow data contain. So typically the counters and the sample. And then what we will do to have traffic is that we will do a regular ping from that system here, that server, to another server on a different subnet. So as I mentioned, we will focus on egress only. So we'll have the S-Flow mode egress specifically on that interface. So we'll configure only on this egress interface. Locally on the collector, this is an overview of Inmon S-Flow trend. You have that dashboard that provides you overall utilization for unicast, broadcast, multicast, errors. You have the top interfaces seen on the being used with all the S-Flow agents that the collector is configured with. So here we've got only one, actually two. I used two in that previous demonstration. Something interesting to note is here the number of samples received per second. So if there is no sample, you will see nothing, but as a matter of sampling, you'll see traffic appearing on that information received sampling. Here that was 10 per second. Then if you click on counter, you'll be able to select which S-Flow agents you would like to select, the interface that is related to the traffic you would like to watch. And typically here you will see the unicast traffic in blue, and here when you see that increase is because I start the ping. The top N information is very important, probably for network operator. You will be able to analyze and filter based on the top source and destination flow. And here you'll see the ingress part that is on the top and the egress part that is at the bottom of that graph. So typically here you see that before preparing that TOI, I activate ingress and egress together. So you've got both statistic on ingress and egress. As soon as I enable only egress, you have no ingress statistic and just egress statistic. And you see that those statistics are with the overlay information, not the VXLAN information. So we'll get back to that during the demo. So typically that's what I was mentioning here. If you enable egress only, you just have the bottom part of the graph that is filled. You have as well a reporting capability. So if you click on report, you'll be able to export, for instance, the top connection, the top source, the top connections being the pair source and destination with exactly which traffic. And you can as well make the top N for all interface. So previously in the graph, you see that it was the top flow source destination for a given interface, or you can have that for all the interface. On the Wireshark side, I will use Wireshark with filtering based on the S-Flow agent IP in order to avoid capturing more. And I will check on the UDP exported packet. So here, typically in blue, you'll see those regular data that are the samples, so the counters. This is counter samples. So the counter samples are just generic information that you get that is more efficient than SNMP polling. So this is a way to have the number of packets in and out of an interface. So even if you are using egress only, you will get the information of both ingress and egress of that interface. The counter sample, if we get into more details here, in order to capture the difference between what is view on S-Flow and what is view in the CLI, I put as well a show interface in order to see the statistic for RX. So as you can see, you have input packet count that is seen, and you have as well output packet count. So regardless of the mode that is being used for the counter sample, for the statistic of the counter, you'll get all information. So you'll see the interface index that is being used for that. You have the operational status that is up. The interface is forwarding. You see that this is the format is generic interface counter, and that's pretty much it to compare to the show interface on that given interface. So the number here between S-Flow and the show interface are a bit different because I did the show interface a while after the S-Flow has been captured. The flow sample now, this is the most interesting part. Here you'll see the obviously the interface index. So I will filter on Wireshark on the interface index. And interestingly, here is the output interface because we are focusing on egress here. So I'm selecting the output interface to explaining you. Then you have the flow data length, so that is being used with the default. The default length was 128 bytes, so this is what we kept as the original packet length being sampled, but you can extend that. And as you can see here, the VXLAN header does not appear. Okay, for egress, again, that would be something fixed later. So it provides you the overlay information, which in my sense is more useful than the underlay information, because here it's probably where you want to track and see the trend of per protocol instead of just seeing the VXLAN UDP traffic. Here you have all the internal. And on Wireshark, as I was mentioning, I will use this display filter in order to analyze specifically on a given interface the filtering and the S-Flow data on that filter, based on that filter. So let's go to the live demonstration. So in this demonstration, we have an S-Flow collector, which is S-Flow trend from Inmon. This is the dashboard that we have. We'll dive into the network. Select which switch is the one that we are interested in too. So that would be this IP. I'll get back to the switch in a while. And we are going to select the interface. So the most important part, so we can drill down per interface. Okay, so you have the chart per interface, or you can directly select the top N, which is usually what the people are interested to, for instance, identify the top talkers on the network. So that would be the top source and destination flows that you have. So here right now there is no data. I'm going to select the port 49, which is the uplink of that VTEP. Right now there is no data. We'll start the traffic, and before we'll get into the switch configuration to identify the configuration. So this is the 6300 stack. So this is a stack. It runs a current test version for 10.7, and we want to see the show S-Flow. S-Flow has been configured, so you have S-Flow is enabled here. We have the IP address of the collector that I was connected to before. The agent IP address, here this is my out-of-band management port. And so as you can have as well as an information here, you have the management VRF. So in the config, you'll see that S-Flow here is the collector is configured with the management VRF to have out-of-band management access for S-Flow. That could be a deployment, for instance, for data center. So let's go back to the show S-Flow information. The sampling, I put a sampling rate that is a bit lower so that I don't have much traffic here, so I don't want to wait too much time. So I decrease the sampling rate. I increase the sampling rate so that we have the ability to wait less for the demo. Polling interval, this is the same. Mode is both, so I'm going to change that. I'm going to only focus on the egress side. And so this is egress now. S-Flow is running, and this is enabled on those interfaces. So by default, again, everything is enabled on all interfaces. So it means that per interface, so if I get to an interface, I had to do a no S-Flow, and you can use the range command on CLI to do that. There is no sample yet because traffic did not start. So I'm going to start the traffic now. So this is with that VM, and I'm sending traffic every 50 milliseconds. So we should see things coming up on the collector. So, probably something like 20 seconds to wait to have a first. Yes, you see now an S-Flow sample has been exported already. So I can go to the show S-Flow interface. Let's say the interface receiving the traffic where the device is connected. So here it's disabled as expected. And now the uplink where I'm actually activating, I did activate S-Flow, enable S-Flow. And here this is successfully sampling. Let's go to the collector now to see what are the outcome and the effect. So then you see that the traffic is seen now. I've got the source IP address, which was the machine I started the ping with, and the destination IP address. So this is identified here. So we can say that now that particular collector is capturing the traffic and have visibility of that traffic. Let's dive into the Wireshark. So as a capture option, again, I'm capturing with the host source, which is the source IP address for the S-Flow, and then I'm going to start capturing the traffic. And I'm interested into that filter, S-Flow flow sample. If I do not use that filter, let's remove that filter. Well, you see, I will receive all the S-Flow information, and I will be able to see as well the counter statistic. So in blue here, that would be the counter statistic only. So if I, so this is the S-Flow data, UDP. So you see that's the UDP port for S-Flow. And the S-Flow Inmon version 5, the agent IP address. So this is important because this is this IP that will appear in the S-Flow collector, and the number of sample. And here the sample is a counter sample, not a flow sample. And in the counter sample, you have interfaces, and here you see that there are many counter samples defined by the size of the datagram that is configured. So here I can check, for instance, for that source interface, or let's dive into this index. The index is 49. 50, 49 is the last one. And you see the those index that correspond to the switch packet being the counter for that interface that is being captured. So this is the counter information. For the flow and the traffic type that is reported in S-Flow, the interesting part is how to identify those flow. So for that, again, I can just for generic purpose, I can simply click on all of those traces in Wireshark. Here, I'm going to select one that include a flow sample. So you see the difference between counter sample and flow sample in the Inmon UDP datagram. So flow sample here, and you have the output interface value, which is used for egress. And so what is here below is the raw packet header, which is the dissected by Wireshark, and here you have the ICMP. You see the ICMP request. The source is my local machines that is pinging the destination. As you can see, there is no VXLAN header, as I was mentioning before. So what I propose is just in order to easily find an interface, you can use the filter that I was describing before. So this is the flow sample indexed, and if you apply that filter directly, you'll get the flow sample in Wireshark. So this is more practical. So we can now maybe activate S-Flow in both directions so that you can see in the ingress direction the VXLAN header. So let's do that. So let's get back to the switch. So I need to configure now S-Flow mode. So I was having before egress direction. So now let's configure S-Flow mode both. Okay, and I'm going to enable again S-Flow. Okay, and now let's do a show S-Flow. So when it's enabled, let's check if there's some sampling being performed. Yes, now we see the increase of the sample, and that would be the same on the uplink interface. I've got now the ingress sample and egress sample here. So let's go back to the collector. And we see on the collector, here we go, we've got the graph updated. So where you see, and we'll see as well ingress and egress appearing here, you have here the visibility of the packet that is the source of the packet that is the local one, the destination being the remote, and you have the UDP that is 4789, which corresponds to the VXLAN traffic. So this is in yellow here. Here are more information on S-Flow in the user guide. So this is the reference for the user guide as of 10.6, but 10.7 is also available. You have the sflow.org, very well documented site where you will find the S-Flow overview, the version, the RFC, so as well here as a reference. And finally, some collectors free tools that we have from Inmon.com, which are very useful for troubleshooting and playing with S-Flow. With that, thank you very much for your attention.